20, part A, B, and C. Now, when we look at an exponential graph, I want you to recognize that unless we see a vertical shift like we see here, a -4, or we see here a +1, that we will have a horizontal asymptote. And that horizontal asymptote will be the same. It's y equals 0. It's the same as the x-axis. So I'm going to start by just plugging in some numbers, and those numbers will be really valuable as I come over here to graph later on. So let's start with 0 in the middle. 3 to the 0 power. Well, anything to the 0 power is 1. Let's plug in 1. 3 to the first power is 3. Plug in 2. 3 squared is 9. Let's go back and plug in -1. 3 to the -1. Now, a lot of people like to see that. We can see that's not happy. It moves to the bottom. Now it's happy, and I end up with 1/3. That's not a 31, 1 over 3 to the first. So I have 4 points here. Let's go ahead and graph those. Here's 0, 1, 1 to the third. I can see this is way far, so 2, 4, and 6, we're right about there. And -1 to the 1/3, we can get an approximation of what this sketch should look like. That's the parent function. We're going to take that parent function and then we're going to translate it. If we ever have a negative sign in front, just know that we're going to come over here to the parent function and we're going to multiply that negative or that value times the y values. If we have a negative sign in front of the x in the exponent position, we're going to take that times the x values as we try to translate this. So let's start with the first one. Think of this as our origin, and now we're going to move our origin in part B. So I'm going to start by taking this. I'm going to move the origin. I'm going to go down 4. Okay, down 4. 1, 2, 3, 4. So this, we can see we've taken this horizontal asymptote. I've shifted it down 4, and now we do opposite of what we think. So you're like, we're going to move to the right 2. We're going to go just opposite that. We're going to move to the left 2. And this is my new origin. So when I think about things and how do I graph this translation, let's see if this works. Give me 1 second. Oh, out of lad. Let's try this one. This is like my origin. So I always tell kids, come back up here and cross those out. You want to be able to denote what you've taken care of. Now I come right back up here. Think of this as my origin. So I'm going to go 0, 1. So this is my origin, 0, 1. And then I'm going to go over to the left 1 and up a third. Over to the left 1, up a third. I'm going to go right 1 from my new origin and up 3. So right 1 and up 3. I'm going to go right 2 and up 9. So right 2. This is 4, 5, 6, 7, 8, and 9. So it's looking like this. Okay. Now, identify the asymptotes. This is not an asymptote. This just allowed me to find out where's my new origin. There's only one asymptote that occurs at the original function. So exponentials just have one asymptote, and that's horizontal. So there's only one asymptote. It's a horizontal asymptote, but instead of it being y equals 0, it's y equals 4. Sometimes students need to be reminded, why is it y equals 4, not x? Think of it this way. This line cuts through the y-axis at 4. That's why it's y equals 4. Every point along this line would have a y value of 4. Okay, let's identify the y-intercept. To identify the y-intercept, remember x is 0. So to identify the y-intercept, x is 0. So I have y equals 3. I'm going to plug in 0 here, and I can't see that. That was a plus. So 0 plus 2 is 2 minus 4. Oops, sorry. 3 squared is 9, and 9 minus 4 is 5. So my y-intercept is 0, 5, written as an ordered pair. And by the way, we can see that it's 0, 5. Wonderful. Now, this is the tricky one. I would love for you to draw an arrow. This negative sign out front is going to correspond to multiplying by a negative sign for the y's. So this is going to become like a negative 1/3. Well, negative sign times -1, and this is going to be a -3, and this is going to be a -9. These just are going to change signs. Same thing here. The negative up above always affects the inputs. So times negative will be a +1, 0, -1, and -2. So when I graph my new ordered pairs, this is what I'm going to. All right, let's go ahead with this. So for this problem, I can see that we're shifting up 1. So my asymptote is horizontal, And instead of it being y equals 0, it is y equals 1. But this is, there's no horizontal shifts. This is a vertical shift. We've shifted up 1. There is no there is no horizontal shift because we know it's here is like x plus 2. This is simply just an x. So if you want to, you can do this, but just know that this is not an asymptote. It just allows us to know, okay, this is my new origin. And now I'm going to graph these points. So I'm going to go to the right one and down 1/3. Okay, right one, down a third. I'm going to go stay and down 1, stay and down 1. I'm going to go left 1 and down 3. I'm going to go left 1 and down 3. 1, 2, 3. And left 2 and down 9. Left 2, 1, 2. And here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And having those approximate points allows us to graph it. Okay, do we have an x-intercept? I can already see it. It's 0, 0. Sorry, it is 0, 0. Now, if I had to show it, remember when we find an x-intercept, if it says, and I'll figure out for Mr. McFarland, you have to show your work, but if we had to find what is the x-intercept algebraically, I come up here, remember opposite, so y equals 0. So if 0 equals -3 raised to the negative x plus 1, I'm going to first start by subtracting 1. But as a reminder, when you see a negative sign, it's like a -1. So I wanted to rewrite this really quickly. Okay, now I'm going to subtract 1 to the opposite side. Then I'm going to divide by -1. So -1 divided by -1, I'm running out of space, equals 1. Oh, I hate this pencil. So equals 1. And I still have over here a 3 raised to the negative x. Still have that. Okay, so what do we have here? Well, I'm trying to solve for a variable, so I'm going to do log base 3 and log base 3, bring down the 1, bring down the 3 to the negative x. This negative x is going to jump in front, and you're like, why are you doing all this work? I personally would just look at the graph and go, oh, x-intercept is 0. But what if Mr. McFarland says you have to show algebraically? That's why I'm doing this. I have log base 3 of 3, this remains, equals, and I have over here is log base 3 of 1. Now, I know this answer here, this answer right here is going to be 1. So 1 times this quantity, I'm so sorry I'm running out of space, I'm going to come back over here. 1 times negative x is still negative x. So negative x equals log base 3 of 1. Okay, let's just do some general thoughts here. If I think about this and I think to myself, okay, think about this. 3 raised to what quantity? I'm going to cover it up. Forget about being negative. 3 raised to what quantity equals 1? What do I need to raise 3 to end up with 1? The only way to get 1 is if this value up here is 0. That makes x 0. There's no such thing as a -0, so x equals 0. And we can see that. We have x equals 0. I will check with him, and if he says you are able to identify the y by simply looking at the graph and the x by simply looking at the graph, then you can just write this down. If he says you have to show algebraically, then we're going to go through these steps.